We're now going to focus on the quadratic function. In earlier videos, we looked at the quadratic function before, and we looked at several other functions, the square root, the absolute value, the cubic function, and so forth. But now we're just going to focus on the quadratic function, and I'm going to review some of the things we already talked about with the different types of transformation. We have our function is ax squared plus bx plus c. And here, keep in mind, a is just the coefficient of x squared, b is the coefficient of x, and then c is just a constant term. So a, b, and c are just representing any real number. So we looked at if we have a vertical shift, we know that if we had the graph of our parabola, okay, so that is just the graph of x squared, and then if we have x squared plus 3, the plus 3 is causing the vertical shift, so it's, remember, going to move everything up 3 units. And then, of course, if this was negative, it would move everything down 3 units. And then we looked at the horizontal shift. Horizontal shift here, notice the horizontal is caused by adding or subtracting on the inside. And once again, if this is our standard x squared, then the plus 3, once again, inside of here, it's going to move the graph to the left. Remember here it's going to be the opposite. So this is 3 units to the left. So there we have a horizontal shift. Okay, and if this was x minus 3, it would move it 3 units to the right. And then we talked about a vertical stretch, and we said that if you have our standard x squared, and if you multiply by a number here greater than 1, such as here we have a 4, that's going to cause the graph to increase at a faster rate. So remember, it's going to go like this, which is called a vertical stretch. And then we said if we multiply by a number out front between 0 and 1, such as the example here, we have 1/4, we have a vertical shrink. So in other words, it's going to push down on the graph, and it's going to make it open up much wider. So that's causing the vertical shrink. And then we looked at horizontal stretch. Well, we're going to have a horizontal stretch, and that's going to happen if we have multiplied by a number here. Now notice this is on the inside now. Up here, keep in mind, when we did the vertical stretch or vertical shrink, the number here that we're multiplying, the 4 or the 1/4, notice this is on the outside of the x squared. So that's causing it to be vertical stretch or shrink. Down here, you're going to notice for the horizontal, keep in mind the horizontal, the number is on the inside. So it's also being squared. So here, the horizontal stretch, that means that this is going to pull this out. So the stretch here is actually going to move it outwards. So it kind of looks like a vertical shrink. So here you have the horizontal stretch. And over here, we're multiplying by 3, a number greater, that's going to cause a horizontal shrink. So keep in mind if this is our standard x squared, and then if we multiply by the 3, that's going to cause a horizontal shrink, which means it's going to squeeze in, so it's going to look like this. And once again, what makes this horizontal is that the number here is on the inside. In other words, it's also being squared. It's on the inside of the function being squared as well. Okay, so that's just a quick review of your different transformations we talked about earlier. And here we have our equation, ax squared plus bx plus c. And a couple things we want to look at here. If we have our a value, and so we want to focus here on the coefficient of x squared, which is the a. And if this a value, this number is greater than 0, then that tells us that our parabola is going to open up. So in other words, if we had something like f of x equals x squared, or if we had something like f of x equals 4x squared, this a value, in this case, this is understood to be a 1x squared, and the a value over here is 4. Just because that is greater than 0, that tells us then that the graph is going to open up. And of course, then just the opposite, if a is less than 0, the graph is going to open down. Okay, so that's just a little bit of a shortcut, some information you know. If that coefficient is negative, if a is less than 0, then that simply means it is negative. So if we have f of x equals simply a negative x squared, or if we have f of x equals a negative 7x squared, because this value is negative, we know that the parabola is going to open down. Okay? So that's an easy way to determine which direction this graph is going to open. A is positive, opens up. If it's negative, it's going to open down. All right, there's some other things we want to look at with our parabola. If we have, this is our parabola here, we know that the point here at the bottom is called the vertex, okay? Now, of course, if the parabola is opening in this direction, then the vertex is the highest point. So again, this would still be your vertex. If it's opening up, then the vertex is the lowest point on the graph. And we're going to have the line, if we think of a line here going right through the vertex, we look at the line here going right through the vertex, this is called the axis of symmetry. And what that means is if you were to take and fold on this axis of symmetry, if you fold the graph on this, then that tells us that this part of the graph is going to fall right on top of the other side of the graph. And so that means it's symmetric with that line. And that's going to always go right through the vertex of your parabola. So basically what that means, if this was our graph, and let's say that this point, the vertex, if this was the point 1, 2, okay, then what that means is this axis of symmetry, this line, well, if we have a vertical line going up and down, then that is a x value. So that means that this would be, the axis of symmetry would be x equals 1. That's the equation for that vertical line. And it's always going to be equal to this vertex value. And here with our vertex, when we think of the vertex of your parabola, we're going to think of the vertex here. The letters we use, remember here, are H and K. So for the vertex, the x-coordinate we think is the H, the y-coordinate is the K. So anytime you're looking for the axis of symmetry, it's going to be x equals H, where H is simply representing, okay, H is simply representing the x-coordinate. So this is just simply your x and y coordinate for the vertex. That's all that that's indicating. So that leads us into the standard form of our quadratic equation, which is a multiplied by x minus h, this whole quantity squared, plus k. And notice here we have the letters h and k, and that's what I was indicating up here. H and k is going to represent our vertex. So when we see h and k, this h here, this k, that's going to be representing the vertex of our parabola. Okay, and remember we said what? A tells us which direction the parabola is going. So if A is positive, your parabola is up. If A is negative, the parabola is going down. So if I give you the following example, f of x equals, let's say, x plus 1 squared. plus 2. Well, here, this is in standard form. We have our a. Now, in this case, there's nothing here in front, so this is understood to be a 1. So here, our a is understood to be 1. And here we have to be careful. We have h. Our h, the formula is x minus h. So here, what is this h? Here, h is going to be a negative 1. And then, of course, k is going to be a positive 2. And if you recall, we talked about the transformations. Think back up here what we reviewed with our transformations. This x plus 3, or the 3 on the outside, the 3 on the inside, that is actually relocating our vertex. So if you think of the transformations, let's just look at the transformations of this graph. The x plus 1 says that we're going to move 1 unit to the left. The plus 2 is on the outside, so that's going to move the parabola up 2 units. So here we have the vertex of our graph, and because the a is positive, we know that it's going to open upwards. So there's a rough estimate of what this graph is going to look like. Now, we know from the transformations, this x plus 1 is going to move it the opposite direction, so it's a plus 1, so it's going to go to the left 1. The plus 2 on the outside says it's going to go up 2 units. Well, if we look at this in terms of the vertex, this here, the x plus 1 and the 2, your h and k, is locating the vertex. So that tells us the x plus 1, the h is a negative 1, and the k is a positive 2. So that's giving us the vertex for this parabola. So again, when you see h and k, you want to think of that as the vertex. So let's see if you can determine with this next example. And again, once I have the example, maybe you want to pause the video and see if you can figure this one out. We have f of x equals a negative 3 multiplied by x minus 2 squared minus 5. And we want to identify the vertex. Okay. And we want to know which way does the graph open. Does it open up or down? And we also want to identify the axis of symmetry. And we want to identify any x-intercepts. So let's see if we can identify those. And once again, maybe pause the video, see if you can do this on your own. All right, so we have the vertex. Well, this is already in standard form. Now, keep in mind our standard form is a times x minus h squared plus k. So our vertex is the h and k. Well, it's this x minus 2. Well, we know that that's going to move it 2 to the right, so that means this is a positive 2, and then a negative 5 says the graph is going to move down 5 units. So we can actually go ahead and plot that point. We know that it's going to be over 2 and down 5. So we're going to go over 2 units and then down 1, 2, 3, 4, 5. And there's the vertex. And now the question is, which way does the graph open? So here's the vertex. And then which way does the graph open? That's based on this negative sign. So that means it's going to open down. So that means it's going to look something like this. And then we need to identify the axis of symmetry. Well, the axis of symmetry we know is going to go right through the vertex. Okay? Well, if this goes right through the vertex, do a little bit better job here. If this goes through the vertex, then it's simply going to be x equals the x value, which is 2. So it's always going to be x equals this value here, which is your h. So the axis of symmetry is x equals 2, which represents this vertical line. And then we want to identify any x-intercepts. Well, where does this graph cross the x-axis? Well, clearly this graph is going down and our x-axis is up here, so we will not have any x-intercepts because the graph never crosses or touches the x-axis. All right, here we have another example. F of x equals x plus 4 quantity squared. And again, we want to identify the vertex. Which way does the graph open? We want to find the axis of symmetry and any x-intercepts. So again, this is in our standard form. We have standard form is a times x minus h squared plus k. Well, you'll notice here we don't have a number here, so the a is understood to be a 1. And for the k, there's nothing added on here, so that's understood to be a 0. So if we're looking for the vertex, then our h is going to be, now be careful, it's not a positive 4, but it's going to be a negative 4 because there's already a negative in the formula, x minus h. So that means down here, this must really be x minus a negative 4. So that's why our h value is negative. And then of course our k value, there's nothing added, so that's simply going to be 0. So what that means graphically, if we look at the graph of this, our vertex is located to the left 4, and the 0, again, there's no vertical shift, so we're right on the x-axis. And then we can look at our a value, which we said our a value here is a positive 1, so that means our graph is going to open up. So it's going to look something like this. And the axis of symmetry, remember, is going to go right through the vertex. So that's going to be x equals negative 4. And the y-intercept, where does this graph cross the x-axis? Well, from looking at the graph here, it's pretty obvious that it's going to cross right here at negative 4. So that's simply going to be negative 4 and 0. Now, how would we do that algebraically? Well, we could take the original function, okay? So if I take the original function, we have f of x equals x plus 4 squared. If we want to find the x-intercepts here more algebraically, then all we're going to do is take and set the function, this is our y value, we're going to set that equal to 0. So we would have x plus 4 quantity squared equals 0. And then we would need to take the square root of both sides. So we would get x plus 4 equals 0. Subtract 4, so we get x equals a negative 4. And we end up with our x-intercept. All right, let's look at another example. F of x equals x squared minus 8. So once again, we want to identify the vertex. We want to determine the direction the graph opens, the axis of symmetry, and any x-intercepts. So once again here, we would have our standard form is a times x minus h squared plus k. So if we want to kind of rewrite this, we just have x squared minus 8. So technically, we would actually have x minus 0 squared minus 8. And then again, there's understood to be a 1 out front. So for the vertex, in this case, we do not have, we don't have an h value, so that's understood to be 0, which means there's no horizontal shift left or right. All we have is the minus 8, which means we have a vertical shift going down 8 units. So therefore, we would go down 8, and that's going to be our vertex. And then, of course, our A value here, which is understood to be a 1, that is a positive 1, so therefore our graph is going to open upwards. So I'm just going to kind of draw a rough sketch here. It's going to open up something like this. And then the axis of symmetry, that's going to go right here through the vertex, remember? So that's going to be x equals 0. And the y-intercept, I'm sorry, the x-intercept. So we're looking at right here, where does the graph cross the x-axis? So here, notice we're going to have two answers because it crosses the graph twice. So once again, we can take the original function. We have f of x equals x squared minus 8. And we want to set this equal to 0. So x squared minus 8, we're going to let the y value be equal to 0 so that we're letting this equal to 0. Or you can say we're letting f of x equal 0. That's all the y value. So where does this function equal 0? Well, we have x squared equals 8. And then we need to take the square root to cancel out the square. And when we take the square root, keep in mind that means we're going to have plus or minus. So we end up with x equals plus or minus the square root of 8. And keep in mind, we can simplify this or break down the square root. I really don't care if you leave it as the square root of 8, but we could think of the square root as 4 times 2, and then the square root of 4, we can pull that out. Square root of 4 is 2, and then we're left with the other 2 underneath. So what that tells us is here, the graph is going to cross at a positive 2 square root of 2 and at a negative 2 square root of 2. That's going to be your x-intercepts. So we would have plus or minus 2 square root of 2, and then of course the y-coordinate would be 0. So in this case, we have two x-intercepts. So when dealing with the parabola, we've looked at a couple examples here where there's no x-intercepts. We could have one x-intercept when the vertex touches the x-axis, or you could possibly have two x-intercepts. All right, one last example, and again, this is one I encourage you to try to work out on your own. F of x equals, let's say, x minus 6 squared plus 8. We want to identify the vertex. Which direction does the graph open? The axis of symmetry. And do we have any x-intercepts? All right, so here we have the vertex. The vertex is our h and k, so here we have 6 and 8, so the vertex is going to be at 6 and 8. So if we look at the graph, that means that we're going to go over 1, 2, 3, 4, 5, 6. We're going to go up 1, 2, 3, 4, 5, 6, 7, 8. And there's our vertex. Our A value, which is understood here to be a positive 1, so the graph is going to open up. So our graph's going to go something like this. And then the axis of symmetry goes right through here, right through the vertex. So that means it's going to be x equals the h value, which is 6. And our x-intercepts, now if we cheat, we can look at the graph and we know there's going to be none. Now let's pretend that we didn't have the graph. If we take the equation, if we take the original equation here, f of x equals x minus 6 squared plus 8. If we set this equal to 0 and we solve for x, I want you to notice what happens here. We would take and we would have x minus 6 squared, subtract the 8 over, so we get a negative 8. Now, in order to get rid of the square, we need to take the square root. And here comes the problem. we can take the square root over here and we end up with x minus 6. And over here we would get plus or minus the square root of a negative 8. And some of you probably already know this, but here we cannot take the square root of a negative number. So what that tells us, there is no real number. This we'll talk about in the future. This gives you an imaginary number or a complex number. So here, when you get the square root of a negative number, that tells us in this case there are no x-intercepts.